Now let's try to discuss about handling large blobs. This is a small pattern, so we'll just try to get this quickly done. So here basically we know that databases are not meant to store bigger files like let's say like greater than 10 MB files. Usually if a smaller files, if you try to store as a blob in DB row and try to query, that's fine. But as file keeps on growing its size, like greater than 10 MB files, they're not meant for the storing of this kind of things. So what is the place to store, and how can we optimize those things and all is the pattern. So ideally we try to see in the Insta, YouTube, or Dropbox, and all these platforms that are mostly related to the files. These are the patterns that will try to fit in systems of that kind. So let's try to understand. So basically first, in the first place, why do we need that blob storage? So like I mentioned, so these are not meant for the binary objects. Are meant for structural data and queries, like properly having strongly typed columns and all, and anything besides greater than 10 MB and NoSQL. So blob storage is the way for us to go ahead and store it. So first, the problem is we don't want to act the file uploads through our servers, because every byte that gets routed through our servers, they add a latency and cost, and it really adds no value to the end users except the bad user experience. So let's say like we wanted to transfer 2 GB of the file. Every time that goes through our API gateway and hits the server, and then we try to store this in blob storage. So here the servers are just like the transport layer, and they are like dumb pipes. They even though they don't want every byte, and they touch. So here like trying to make it go through a server, like going direct tries to bring problems. Like maybe let's say like 99% is done, and it some due to network problem or so it collapsed, and so on. So it needs to start all the way again to upload, and everything should go through a server, and it needs to handle the traffic, and so no progress and all. So there'll be no progress tracking and all the status drift and all. So we need to avoid now. How can we just keep our main servers also just out of the loop of intaking the file from the client? That is the the mindset or the thought process that should be when we are trying to handle this blobs. So for that basically here the solution is trying to make the server as the access layer instead of transfer layer. So here what we do, basically we try to give a client temporary scoped credentials, kind of so that they can use that URL to directly upload to the blob storage instead of keeping the server as the intermediate layer. So that way now we are trying to turn this server from the transfer layer to the access control layer. So that's the thing. So we send these client credentials to this client, that is that is called basically presigned URL, and once the client gets the presigned URL, it can transfer the bytes, whatever the file that it wants to send, directly to the blob storage. So that's the thing we wanted to avoid, and make this server less data access as the approach. So now let's think about the simple direct upload. So it's a simple and straightforward. The server, whatever it is, this hands back our server, it hands back the presigned URL, and this client, what it does, it tries to put the file straight to the blob storage through this route, so the one that I just discussed. And now we are completely detaching this from the blob storage. So that's the pattern. And here this basically this request signed URL presigned URL is a two-way. So this clients puts this URL to this URL whatever we send, then the server just whatever it just tries to create with whatever the secret access key and all that we have, the env values that we try to set with local creds, and there'll be no network call even to blob service and all. So this URL, what that ideally will have is basically the credential and a date and expiry and plus signature. That is what it carries, and once it sends that to the blob storage, then it will have its the secret key that we used to send that URL with the signature, and it will verify and it will try to take that file and upload it to this blob storage. So and we can control, basically it will have like content length range and maximum per that URL, and also basically that's a way to avoid malicious actors who upload like let's say 100 GB 1 TB or so. Instead of that, we can restrict them to like 10 MB or let's say like 20 MB or so per this content length range, and also the type. And we like this we can restrict not to upload video for the blob that is created to accept the images. So this is a simple direct upload. That's the simple process, and the download as well. So basically signed URLs give the temporary read access, and this will try to serve from the CDN, like trying to provide an option for the end users which is frequently accessed, and they can directly try to download from the CDN edges near that user. So simple here as well, client gets the signed URL and then downloads directly. This we have this here two ways of signing that thing, blob signatures. So those are like basically S3 pre-signed. So this will be completely validated by the storage itself with the secret access key whatever we had created from that respective cloud. And the CDN signatures, basically this CloudFront that I was talking about, CDNs, so they are usually validated at the edge using the public and private key cryptography. And basically we the client holds the private key and signs the URL, and the CDN has the corresponding not the client but our server, and the CDN has this corresponding public key, and it will try to validate that signatures at the edge locations and all. So that's how like we facilitate even the download without our server being in the picture. And now let's talk about the resumable uploads for large files. So that's very important feature, and also it's like pretty standard these days. Any application which involves file intake by default all the cloud offers this. So so idea is to try to split big files into smaller chunks. So for example, AWS allows us to upload in the 5 MB chunks, and instead of trying to upload maybe 5 GB or 10 GB at a time. So the problem there, just imagine, let's say we have like 10 GB video and like let's say 5 GB and we have some network speed of like 100 Mbps or so. So ideally to take around 7 minutes or so to upload that complete file. Let's say in between or like at the end like 90% or so we lost the connection, then again we need to start all the way from scratch. So that's something we do want to handle, and it's something we want to avoid that. So that is where like for example S3 if we take, it provides us the multi-part uploads where each 5 MB plus gets its own pre-signed URL. So even if let's say we have 100 parts and somewhere we lost the connection once we send the 60 parts or so, and now the client will resume from 61st part onwards instead of starting all the way from the zero. So that's this multi-part really helps us to resume from the part at which we failed, and the idea is to split into chunks and try to upload this. And basically once the 100th part is done, so and the blob storage tries to stitch into one object, and all the chunks now it's completely it's something, it assumes those chunks are not part of the blob anymore. So that is where again we need to have some lifecycle rules like trying to clean up every 2 days or so, because storing in the blob is going to cost us money. So just to avoid, because anyhow we'll not be able to use those chunks, or we'll not be using directly, we'll try to use the one storage which it has stitched to. So that's the thing. And the progress tracking is very important when we wanted to show as the on the client side as a best user experience. Basically progress is nothing but the parts done by the total that we have. So we'll try to finish with the completion call once all the parts are uploaded, and that completion call to the blob storage, it will be like passing in all the part numbers along with the checksums for that thing, and then it will use that to stitch all of them into the single object, and then it says like now I'm no longer in charge to the chunks, and it's your responsibility to clean up or keep it. And so that's the multi-part upload usually we try to take in. And now let's try to see how do we synchronize the state. So basically we know that now the server is completely detached from the blob storage, and now how do we maintain the state synchronization between our server and the blob storage? So that is where, like, we know file lives in blob storage, and its metadata, usually the pattern is like we're trying to maintain in our DB, and so keeping them in sync is kind of like something we need to be very careful. So there might be scenarios that file is stored in the blob, but the status is not updated in our metadata DB, and it can be vice versa. There can be race conditions, that is, database might show it's completed, but the file doesn't really exist in file storage, and again vice versa. And also malicious clients might make the uploads as complete in our metadata DB, though they have not uploaded anything, and any network failures and all. So those are the problems, race conditions, orphan client, and malicious actors, and then network completions. So this basically we need to be very careful here, and that's where, like, how do we handle that state the sync once the 100% of the file is completed and uploaded in the blob storage, and how are we going to handle? So we have the concept of like event notifications. Usually blob storage really helps us to provide those event notifications, so that now instead of relying so the above problems arises when we are trying to rely on the client side. So we are relying on the client side, like, once it's done, please let us know so that we can update in our metadata DB. So instead of relying on the client, the idea here is to try to rely on the blob storage itself. So that's this idea, that is more reliable, and also that's what it's adopted mostly. So state sync, we try to adapt this event notification that blob storage provide. So this what it does, the storage itself confirms like what exists and all, and also this reconciliation idea is basically, let's say we might miss few of the blobs event notifications, or some of the rows in the DB might still stay it as a pending and all. So we might do periodic job that that catches all of this pending things, and we try to scan in the blob storage and get the status, and we can update the status. So idea is simple. The client and the API gateway server and anything related to metadata, we try to listen to this event notifications and update our row in our primary DB. The idea is simple. Storage really emits an event and upload. We update the DB row status, basically, like, it's a pending, and we have the storage key and all the those things, and once it is done, we will try to find that row with that storage key and update the status as completed. And even trying to send from the blob storage, that might fail. That's where, like, reconciliation job basically tries to help us to recheck that file stuck in pending, maybe few hours or so, whatever the interval that we want to do, so that even this the ones that we are stuck, we'll try to make sure that we update it. So that's the overall the pattern. Basically idea is to try to detach the server completely from the client and the blob storage, and let them take care of the things, and for syncing to our application server with the blob storage, try to rely on this event notifications and reconciliation. That's all. That's the whole idea of this handling large blobs pattern, and nothing much in here. And now this try to get this with jargon, so nothing much to learn here. Basically we have major cloud providers, AWS, GCP and Azure. Their terms are different, but features are something. Upload URLs, it's called presigned URLs in AWS, and signed URLs in GCP, and SaaS tokens in Azure. Multipart, we call multipart upload in AWS, resumable and blobs in Azure. Events, S3 events, and here we have this PubSub separately in the GCP, and here it is event grid in Azure. So CDN side, it is like this CloudFront is what is known in AWS, and Cloud CDN and Azure CDN in GCP and Azure. Cleanup basically will have the lifecycle rules that, like I just mentioned, those chunks we can configure some lifecycle rules and get rid of them, so that we can save some of the costs that will incur if you try to store in our blob storage. And it's called lifecycle management in GCP, and lifecycle policies in Azure. So that's some terminology, just to better to get used to it. And now identifying like basically when to use and when not to is very important. So that's when only we'll know like this pattern will be applied in these scenarios. So simple rule, like I said, like if the files are greater than 10 MB, then straight away this the pattern that we just discussed is something that should trigger our mind, and we should try to just talk about it and implement this. So yeah, so basically greater than 10 MB, completely move from our server and use this presigned URL that basically we get out of the box from the cloud providers. And that's the thing. That is the only situation when we need to straight away think of to using it. And common scenarios like systems that we normally use on day-to-day basis, that like video related platforms, let's take YouTube, Netflix, or whatever it is. So everything we always like big files, 10 GB, 20 GB and all uploads we need to handle through presigned S3 multipart that we mentioned. And then once it is completed, let's say 100% is completed, now we know that S3 will have this event notifications and all those things. And using that the other worker process, let's say transcoding or transcripting, and then other whatever the heavy worker processes that we can want to trigger, event notification will be a triggering point for those workers to start once the video is completed. So that's how like the one of the real use cases in applications that we use on day-to-day basis. Photos as well, let's say Insta or whatever it is, we try to upload like 50 MB plus photos and all. This also like we try to bypass the API and try to adapt this pattern. Again, event notifications, maybe we need to create some thumbnails or apply filters or whatever the sound, music, or whatever they have attached, and all those things we rely on this event notifications for those workers to process further. And file sync, the Google Drive, Dropbox, and all those things. Chunks will try to upload to blob. And this again multi-part upload pattern, we try to maintain that. And also this files share this generate time limited signed URLs that work without the recipient really having that Dropbox account. So even if you wanted to share the URL to the person who doesn't have that really account, the signed URLs will help them to access that. So this way like this pattern really helps to adapt to those scenarios as well. And chart also intake like WhatsApp and the other things that we use, media uploading and all falls back to the same pattern that we just discussed. So that's the thing. And again, we should also know when not to use. This is simple, small files less than 10 MB, don't even think about this pattern. That's the thing. And also synchronous validation is something is mandatory, and it's something is needed. Then just stick to this simple pattern, and don't even think about detaching the server from this picture completely. And also we have a need for compliance and data needs, like we need to scan before storage or so, like try to handle this for compliance reasons and all. This pattern again doesn't work. And this when the experience or tries to demand immediate response, like users expect instant feedback based on like file contents, like let's say like photo profile photo appearing immediately with the like face detection or so. This async nature of like from the client to blob storage really doesn't work here. So we need to be synchronous and try to not to use this pattern. That's the thing. And just the common situations, what happens when we upload fails at 99%, and we know that chunk uploads resume from the failed part, and that is where, like, we need to rely on this multi-part upload and understand that pattern. And it's not like, we'll do all the way from the scratch. So that's the thing. This query uploaded parts, it has like AWS has list parts, session status, and committed blocks in Azure and GCP respectively. They resume from the failed ones instead of starting all the way from one. They track this session ID, this upload ID, and resumable URL. Like, basically they try to store in the local storage to survive when the restarts, like let's say mobile, where it has like least network connectivity. So in that situations as well, this really helps to continue even if they have like low data or low network and all. So this basically this if it fails in between, and if you don't know this pattern, the incomplete parts that are stored in blob storage cost us money. So that's something also we need to take care of it. And we need to definitely configure this lifecycle policy to clean them up, or maybe after every one day or 2 days or so. That's the like how do we handle those things. And like trying to prevent abuse, like a user trying to upload 100 MB file for just 1 MB restricted blob URL, presigned URL. So that in that situations will not let the user to directly upload to our blob. We try to introduce a quarantine bucket. So basically as a temporary file bucket, and there we'll try to look for scanning viruses, file type, and then basically an additional layer before our actual public bucket that we try to expose, because they might upload some malicious content and all, like the thing that is not usually encouraged to be viewable by all audiences. So those are the things, like we can try to handle this kind in these situations, and prevent abusing our storage, whoever is trying to use our generous offering and all. So that's what we need to first level is always try to cap file size in the presigned URL conditions itself, like 10 MBs and all for every chunk. And then this introduce this quarantine bucket, and that's the only way to prevent abuse and all. And now the handling metadata, this we have already discussed. We always try to create a DB record at pre-signed URL generation time itself, so that we'll have an entry and the storage key and all. And after that only we give that URL to the client, and then client uploads through that URL to the blob storage. And once it's done through event notifications, we will receive an event, along with that the storage key. We'll look for the row using that storage key and update the status to completed. So that's how the pattern we try to always maintain this way, and that is what this is all about. So these are basically the kind of scenarios that we try to always look for, and see how can we improve, and also how do we ensure faster downloads. You saw the simple direct download. Try to introduce a CDN at the edge cache locations nearer to the user, so the turnaround time for them to look from the actual region where the blob storage is available will be reduced. And this CDN introducing for geography, and also this range requests for resumability. For example, first request, what let's say now I'm trying to get the file. I'll directly get from the blob storage. Let's say if it takes 200 milliseconds, and I know this is frequently accessed, then now I'll try to cache at the CDN edge, and next time whenever user tries to access that, we get the cached copy, it'll be just the 5 milliseconds. So you see the difference between 200 and 5 milliseconds. And then we have this range request. So this, whenever we try to download, this is quite opposite of the multipart, and whenever we try to download, whichever is missed, only that bytes it tries to download, and making it as a faster using the local storage that we have. And so these are just the rough ideas and the ways and the solutions to handle all these kind of situations, and thus how do we handle big files and large blobs, and how can we fit in these solutions or so in the systems that we'll be discussing. So this is a simple one, simple pattern, and just you need to understand when to use it and when not to use it, and how it works at a high level. That should be it. Let's catch up in the next